Hi guys, this is Fatima and today I want to find the general solution for some second order differential equation. This is our first equation, and as you can see here it's equals 0, so it's homogeneous. And the other thing that we have to notice that the coefficient for our double prime, y prime and y are all constants. Okay, when it's all constant and homogeneous, so when it's really easy because we have to just write the characteristic equation. Okay, so when we have an equation in this kind of forms, when it's all like this and it's equals to 0, we write the characteristic equation for them, and the characteristic equation will be in the form of like this. Okay, so we're basically turning our differential equation into polynomial equation. Okay, after this we have to find the roots for this equation. Okay, and for finding the roots we use a delta equation that it's like this, and three things might happen. We have three cases. One is the delta is positive. Okay, then we have two roots, r1 and r2, or the delta might be equal to 0, then we have just one root, and delta could be negative, then we have two roots, and it's kind of in the form like this, complex. Okay, so for each of them we're gonna write the general solution with which they have different forms, and I'm gonna tell you about all of these things that how it be. Okay, so let's solve this equation. If we write the characteristic equation for it, the characteristic equation would be in the form 5r plus 6, right? It would be like this. Then we find delta, this is b, here we have a, and this is c. So it's b 25 minus 4 plus 1 plus 6. This is 24, so it's equals 1. It's positive. So we have two roots. R1 and R2 would be like this. Our delta over 2a. Okay, so delta b is 5, b minus 5 plus minus radical 1, which is 1 over 2 over 2. So we're gonna have minus 5 plus 1 over 2, which it's gonna be minus 2. This is one of our r, and we're gonna have minus 5 minus 1 over 2, it's gonna be minus 3. This is gonna be our r2. Okay, so we find the 2r. Now we have to write the general solution. When delta is positive and we have two roots, the general solution would be in the form this: e r1 t plus c2 e r2 t. And if we write it for our equation, it would be like c1 e minus 2t, r1 is minus 2, plus c2 e minus 3t. That's it. That's our general solution. Okay, so what if the delta wasn't positive? Okay, let's solve this one. Homogeneous, they're all constant, so we just write a characteristic equation. It'd be like r2 minus 4r plus 4 equals 0. And if we write a delta for it, it will be minus 4 plus 5. 60, 60, it's equal 0. Okay, when it's delta equals 0, we have just one root, and it be like this. So it's 4 over 2 equals 2. When it's like this case and we have just one root, the general solution would be in the form y c1 ert plus c2 ert. Okay, so if we write it for our equation, it would be c1 e2t plus c2 te2t. That's it. Okay, so what if it's negative? Delta is negative. Let's solve this one. Homogeneous, it's all constant, so the characteristic equation would be 2 minus 2r plus 4 equals 0 here. This is this part, and the coefficient of our double y double prime would be coefficient of our 2. Okay, so if we write it, delta would be minus 2 over 2 minus 4 plus 1 plus 4. Okay, so we have 4 here minus 16, so it equals to minus 12. Okay, if we try to find the r1 and r2, it will be like over 2a would be like 2, because our b is minus 2, so it will be 2 here, plus equal radical minus 12 over 2. Okay, and under the radical we can have a minus. When we write it like this, 12, and we say it equals I, imaginary. Okay, so we write it like this, and the radical 12 is actually radical 3 plus 4, and the 4 can get out and be 2 radical 3. So instead of radical minus 1, we write the I, and instead of radical 12, we write it 2 radical 3 I over 2, which is equals to 1 minus radical 3i. So in general, when we try to solve it and will be like this, we have a form like this, plus equals bi. And when it's like this, the general solution for this kind of differential equation, we write it like this. We say it would be e the a t cosine b t plus c2 e a t power, okay, sine b t. So if we write it for our equation, our a is 1 and b is radical 3. It be c1 e t cosine radical 3t plus c2 e t sine radical 3t. That's it. That's gonna be the general solution for this kind of differential equation when we our delta for the characteristic equation is minus. It's negative. Okay, that's it, guys. Thanks for watching.